happy to give the floor to my dear colleague, Shravan Chunduri, who has worked with our team a lot on our latest and actually first TOPCon report, I believe, and he will share his results. Shravan, the floor is yours.
Thank you, Michael. I'm just sharing the screen. Okay, you can see the screen, right?
Yeah.
Okay. Hello, everyone. Welcome to my presentation. Today, I'm going to provide an overview on our recent report on TOPCon Technology, which we published very recently. Before going into the main topic of my presentation, I would like to give a brief introduction of our company. So we are actually two companies and we have two platforms. TaiyangNews is an open solar news platform where we publish all related market surveys, technical reports, and also we cover the technologies. And our Mishko is our consulting arm where we provide communication strategy development and all consulting related market intelligence services. So TaiyangNews has been publishing reports on important technology topics. In fact, TaiyangNews has also covered the TOPCon extensively, but not exclusively in past as part of our report on high efficiency cell technologies published in 2019. So we recently published the latest updated TOPCon report at CSPV conference. This report is also available for download for free at the report section of our website, like any other report. So a few words on the report. In addition to the basic different cell technologies, the report also deeply discusses the processing intricacies of TOPCon, especially the deposition technologies, additional processing steps when compared to PERC, and metallization. And then we have also provided an overview on cell efficiencies and module powers commercially available. And the report also outlines the commercialization status, challenges, opportunities with the technology. And then we have also included an interview from Jia Chen, who is the technology head of Jollywood, which is the leading TOPCon supplier in today's context. Okay, here I will quickly guide you through the different high efficiency cell architectures, progressing from PERC to IBC. Probably I don't have a lot of time to explain everything, but what you can see at a glance, what you can see is the most important difference between all these advanced cell architectures is the metallization and then also the passivation scheme. So this is also the case with the TOPCon. Actually, TOPCon is a name for the passivated contacts developed by Fraunhofer ISE. Okay, so here is the basic structure of the TOPCon. So today's industrial TOPCon is implemented on N-type on the rare side. So that means a stack of a tunneling oxide and doped polysilicon are added onto the rear of the typical PERC cell. So many believe that the TOPCon is in line of extension to PERC. That's because it is very close to the current mainstream, which is PERC in terms of manufacturing. So the crux of the process are applying a ultra thin silicon oxide film and a doped polysilicon layer on top of it. So there are actually several variants of the process flows for the passivated contacts. So depending on the equipment, also the philosophy of the process. So the flow chart here, what you see, it is from the Jollywood, basically comparing, benchmarking it against with PERC, and Jollywood has been presenting two process flows. So one is based on ion implantation, another is focal diffusion. And of course, as far as the main process, they have been using LPCVD based process. And here, when you compare to the PERC, the application of the rate stack comprising of tunneling oxide and polysilicon layers, replacing the aluminum oxide deposition are the very obvious changes. But then whether the polysilicon layer which is applied is doped in situ or external, this also determines the process flow. And irrespective of the deposition technologies, which I will cover later, so the process definitely requires some additional cleaning steps on the front side, and a few steps more compared to PERC are emitter formation with boron, which is often more complex than the typical phosphorus emitter formed with the PERC cells. And same as with the heterojunction, cleaning is also very key to the success of the TOPCon. So specific solutions for wet chemistry are available from companies like RENA, and there are also some special cleaning solutions available from CSPV, which you will hear in the later part of this conference. So when it comes to the manufacturing of the passivated contacts, the core of the process lies in three steps, as I said earlier. So application of interfacial oxide, then deposition of intrinsic polycrystalline silicon layer, and doping the polysilicon. So as during the inception days of PERC, like when nearly every known deposition technology was promoted for the deposition of aluminum oxide, it's actually happening the same with the TOPCon. So currently LPCVD, PECVD, PEALD, and PVD tools from different vendors are promoted for the core job of producing passivated contact cell structure on the array. However, LPCVD is the most widely used technology as of now. But PCVD is really the next popular technology. Then we have PVD and PEALD, each of which got a vendor, and also they found place in commercial development of the cell manufacturers. So most of these other technologies, apart from LPCVD, they have all finished the testing phase and are very close to be implemented, or already being implemented in commercial production. So talking about the LPCVD, it's actually very widely used process in the semiconductor industry for depositing polysilicon and even doped polysilicon. So that is exactly what is also needed for TOPCon. There might be really few others there in the market, which I'm sure, but we were actually able to collect the data for 5, but I'm here only listing 4: Centrotherm, SE, Semco, and Laplace. In our report, we have also included Pola PV, but a very little information is available. So that's why I omitted them from this presentation. And actually, these companies are really offering a different reactor design. As you can see, they are offering, Centrotherm is offering 10-stack tube design, while SC is providing option between 4 to 6. Semco and Laplace are providing 6-stack configuration. So then different companies are also recommending different level of process integration. So what I mean by process integration here is, whether doping steps are included, and is the application of tunneling oxide is integrated within the tool or not. And so all these steps are going to influence the throughput. So that's why I deliberately deleted the throughput information here, because it will only cause confusion. And whereas if you go to a report, you can see the throughput information, because all the boundary conditions are well explained, which I cannot do in such a short time. So, but what I can confirm is all LPCVD tools grow tunneling oxide and polysilicon, and in situ doping is at least as an option. And there are, as far as the throughput, there are systems up to 6,000 or even 8,000 wafers per hour, referring to the larger wafer formats like M10 and G12. So another important aspect of the LPCVD is their ability to deposit thinner layers of polysilicon without losing the uniformity. So layer thickness also influences this throughput. That's very important here. So now the current systems, they can deposit down to 80 to 100 nanometers, as you can see here. But yeah, so the general practice for the LPCVD system is, in order to improve the throughput, they typically employ a back-to-back loading. That means 2 wafers are placed in a single slot. So, but this might work for others, but this is especially problematic for LPCVD because the precursor penetrates into the gaps between the wafers and causing a parasitic deposition on the front, which is usually colloquially in industry called as wraparound. So, and then there is also another problem that's challenging of processing the larger wafers in these LPCVD reactors, because when you are placing back to back during the dynamic processing environment in the reactor, during the heating up phase or cooling down phase, the wafer shakes slightly, vibrate. So then there is also a chance for the breakage. And there is another big problem with these LPCVD reactors is the cracking of the quartz tubes, not just the quartz tubes, even the quartz ware, because there is a huge variation between the thermal expansion quotient of polysilicon and quartz. And since the reactor, the mechanism of LPCVD that it deposits everywhere. So all this polysilicon that is sticking onto the quartz ware as well as the quartz tube, it grows to a level, and then during the processing, the stress created due to the mismatch of the coefficient of thermal expansions is strong enough to break the quartz tube as well as quartz ware. So a part of solution came from Semco. Actually, they started offering this solution 10 years back, which they actually developed for the ribbon wafers, which do not have a fixed form factor. So this trick is doing the processing in horizontal orientation. So the wafers are processed in horizontal orientation, which can, of course, kind of at least bring the wraparound into a controllable level. And then it also allows processing of the larger wafers without a lot of breakages. And later Laplace also started following the same method. As far as the life of the quartz tube, Semco has developed a stainless steel reactor, whereas Laplace still remained with the quartz philosophy. So addressing the shortcomings of the LPCVD, especially the wraparound, then PV industry really started focusing more on PECVD technologies. So right now what we see is Centrotherm, SC and Jinchen have developed the PECVD based solutions. And recently we also heard idle deposition, which was supplying their tools for ALD. For aluminum oxide deposition, they have also entered into the stream. And the main advantage of PECVD is, first, it's very well known in the industry. So people are very well aware, and it's a lot of companies know how to operate and maintain these systems. And then it allows a very easy integration of the process. That means you can do the tunneling oxide, and then the polysilicon and in situ doping, all can be done in one step, and it's quite easy. And there are and even Semco is also trying to follow the same method of PECVD, though they have already a robust solution with LPCVD. When it comes to PVD, actually Fernandez was the first to initiate the development activities in the direction of TOPCon, but JTI was the first to commercialize a reactor based on PVD, though technically it also falls under the PVD category. JTI calls it as POPADE, which stands for plasma oxidation and plasma assisted in situ doping. Actually, technology is much more than PVD, because it combines the PVD with plasma oxidation. That means, unlike the traditional PVD tools, you can also accomplish the oxidation. That means the growing of tunneling oxide in PVD. And you would hear more from Jollywood, because Jollywood has considered the POPADE technology for their next expansion plan, and Jollywood, their JTOPCon 2.0 version of technology. Then PELD is another interesting technology, which is essentially a combination of PECVD and ALD. So not so much of information is available for this particular technology, because Lead Micro is the sole contestant here. What we learn from the data sheets is it's a dual size processing tool. So that means once you put the wafers into the reactor, it can do all the tunneling oxide requirements and the passivation requirements on the rare side. And then it also deposits the required passivation scheme on the front side. So it looks like it has low throughput, but when you really want to decouple the process, it can more than double the throughput. So coming to the comparison of these deposition technologies, so here is a brief summary. As I explained, LPCVD got this problem of wraparound and quartz ware breaking. And by doing the horizontal process, horizontal wafer orientation, some of these can be addressed to an extent. And then PECVD is really the next popular technology, where it is almost addressing all the bottlenecks of LPCVD. And then PVD and PEALD have found at least one serious cooperating cell manufacturers. I think their first results are also quite encouraging. Then metallization is also very important topic for the passivated contact. So compared to PERC, it really requires double the silver. But as far as the metallization is concerned, TOPCon uses a aluminum doped silver on the front side, whereas it uses a low temperature cured silver paste on the rear side, because the rear side metallization is very important, where the penetration, the sintering rate of these contacts has to be very controlled, so that they should really contact, but at the same time they cannot puncture the rear junction. So they cannot puncture the rear passivation scheme. So there are quite opposite requirements. Earlier there was some challenge, but as we already included in the report, leading companies like DKM, they are ready with the solutions. There are commercial available products, and the paste consumptions and laydowns are closely following as to that of PERC. But here there is also plating that can be effectively used. So in one of our previous conferences, Reina has presented the plating solutions that very much fits into the TOPCon requirement. Coming to the efficiency, so if you are attending any of the TOPCon event, it would be probably very hard to miss a slide that, okay, TOPCon got very high efficiency potential even compared to heterojunction, but true, but as far as the reality is concerned, heterojunction still holds the highest efficiency record. And as far as and recently there has been a lot of progress in the industrial efficiency, industrial efficiency records. So Jinko and Longji, they were kind of competing with each other. Until we published our report, Jinko was still holding the highest record of 25.25, but recently Ningbo Institute of Material Technology and Engineering, along with using Jinchen's equipment, has reached 25.53% efficiency. And what is also interesting is here Longji has also made a record of 25.19 with the P-type TOPCon. And the commercial TOPCon module offerings are actually very few, because most of the companies are only running testing lines till now. Jollywood and LG are very well-known companies in this area. Then Trina Solar started offering modules, commercial modules, in 2019. Then recently Jinko and SPIC have also joined. So Jollywood apparently offers the most versatile and distinguished product range, applications varying from rooftop till the utility scale. LG is more focusing on the residential scale and a little bit also on the C&I side. But the highest module power so far we have seen in the commercial modules is 700 watts from Jollywood. But you might be thinking there have been several modules that were introduced at SNEC. But yes, we know that, but we haven't deliberately put it here, because often we get a complaint that we are comparing apples to oranges, because some products are still prototypes, and these are sometimes they remain to announcements, and these are really the commercially available products. But in our report you can see both the modules which are introduced at SNEC. So TOPCon got a few limitations. So it is not yet clear what kind of technology, what is the mainstream deposition technology. As of now, all deposition technologies are under use. And it has a silver consumption, which is double compared to PERC, because it is also a N-type structure. And TOPCon relatively suffers a relatively low bifaciality, because there is some kind of absorption on the polysilicon layer, which is on the rare side. And it has a low compatibility. Of course, this may change in low compatibility with the P-type, but this may change in future, because as I just mentioned in the earlier slide, Longji has also developed a P-type TOPCon. But for any technology, be it TOPCon or heterojunction, I think PERC is going to be the main contender, and it is also going to challenge TOPCon. So, and backed by the rapid introduction of the larger and larger wafer formats, PERC is becoming even more competitive and creating a bigger gap between the other advanced technologies and heterojunction. But this may not be applicable in a short term, because TOPCon is also kind of scaling up in terms of larger wafers. So here I come to the conclusion. So TOPCon is really viewed as extension to the PERC. LPCVD is the most predominant technology, but all other technologies are also gaining up equal interest. PECVD is the next biggest one. So PACE, which was a problem earlier, now it's also getting into the mainstream. So issues with the deposition methods expected to be addressed very soon, and low bifaciality and competition with PERC are expected to stay the same. Thank you very much for your attention.
Thanks, Shravan. Nice overview. So to everyone again, so if you want to read more, please download the report. Shravan, I think there were a few questions, comments in the chat. You might want to address them there. Then we continue with the next speaker.